This is the continuation of topic 1.3, example 5. So we're still going to be looking at limits from both the left and the right side. So here again, if you guys notice what's different from these problems is that we have pretty much a limit that is approaching the left side and the right side. We have a continuous line there. So there's no gap in between these two. So that's one of the nice things about these. So the limit as x approaches 0 from the left side here, we can say that it's approaching positive 1, right? That's where the y-axis is at, f of x is at. So the limit as x approaches 0 from the right side, it also equals positive 1. So therefore, I can say that the limit as x approaches 0 from both the left and the right match, right? Those two are exactly the same. So we can say that this is equal to positive 1 as well. And then since this is a continuous line, we can say that f of 0 is also positive 1. And we're done with that one. Example 6, we have the limit as x approaches 2 from the left side, and we have an asymptote at that point right there, if you guys notice. So remember, when we see an asymptote on the graph, it's when it's in undefined. So probably f of x right there has an x minus 2 in the 0, and that's causing troubles in the function itself that we cannot divide by 0. So here the limit as x approaches 2 from the left side. If you guys notice, it goes straight down. So that's leading us to negative infinity. And then as x approaches 2 from the right side, the graph just goes straight up. So therefore we can say it's approaching, or it's going to positive infinity. Now here we want to be careful because the use of the equal sign means that we're going straight to a value, right? We're going straight to a number. Here I would say I would put more of an arrow than an equal sign. So we have to be careful, right? If we're using the symbol equals, that means that it is exactly equal to that value. And if you guys remember, infinity is not actually a number; it's more like an idea, right? It's a non-ending number, pretty much. So I can say that the limit as x approaches 2. Since these two don't match, right? They're not going towards the same numerical value. I can say it does not exist. And then here, if you notice, since we do have an asymptote at f equals f of 2, we have our function happens to be undefined. All right, a lot of people tend to confuse those two. The limit as x approaches 2 here does not exist, and then f of 2 is undefined. So make sure you guys keep in mind those two. All right, they're completely different things. And the last example here for this part of the video, example 7. So now again, the limit as x approaches 2 from the left side, negative 2 from the left side. We're going towards negative infinity. And here, so negative infinity. And then the limit as x approaches negative 2 from the right side is also going towards negative infinity. Now, you do want to be careful here because even though these two are going towards the same place, right, we still have to make sure that we're saying that these two, since they are going towards negative infinity, I'm not going to say that the limit as x approaches negative 2 of f of x equals negative infinity. In reality, the limit does not exist because we're not going toward a specific number, L. So here does not exist. And again, we are undefined. We have an asymptote, but if you guys look at the graph closer, it has this closed circle right there in the center of it, right? So therefore, I can say that f of negative 2 is equal to positive 0. So you guys got to be careful because they want to trick you guys on the test, specifically like with those little tiny details.